Welcome to training video number 9. This will apply to both Test Pro and Network Service Assistant, and we're going to be covering the OTDR today. I'm going to be using my NSA with the OTDR adapter in it. The exact same testing process would take place whether you're using an NSA like I've got here, or a Test Pro unit, or if you've ordered the OTDR as a standalone with a Test Pro handset and the OTDR adapter. I'm doing single mode today. Multi-mode is going to be exactly the same process. All the project setup is the same. You're just going to choose multi-mode instead of single mode. But the basic process is going to be identical. So before we dive into the actual OTDR setup and test, I want to go ahead and talk a little bit about what an OTDR is for. We're going to talk a little bit here about Tier 1 OTDR and Tier 2 certification, just to make sure that everybody's on the same page here. There does seem to be a little confusion in the field when it comes to Tier 1 versus Tier 2 and what does OTDR do. So we're going to cover that briefly. Tier 1 optical loss testing. This is what you commonly know as fiber optic certification. It is a dual-ended loss measurement on the fiber. Sometimes it's dual-ended single direction, sometimes dual-ended bidirectional. And it measures the loss using a light source on one end and a power meter on the other end on each of the two fibers. The setup is done using standards prescribed test limits, which provide the limits for the length of the fiber, a loss per kilometer, and it provides the loss value for the end connectors as well as any additional connectors or splices. And the optical loss test set calculates everything when it runs the test. It takes that loss into account based on the limit you've set up. OTDR testing in itself is not certification. OTDR testing is a troubleshooting tool. So an OTDR is an optical time domain reflectometer. Essentially, it's sonar with light. It's sending a pulse of light down the fiber, and it's looking for a reflection. Based on the strength of that reflection and how long it takes that reflection to return to the OTDR launch port, a lot of information can be gathered. We can determine how strong the reflection is, which indicates how much loss we may have at that connection point. Based on the type of reflection, the OTDR can determine is it a mated pair of connectors, is it a splice that's got an issue, could be a fiber mismatch depending on how the reading shows on the trace. So all this is taken into consideration on an OTDR trace. It's a really good troubleshooting tool if you've done that Tier 1 optical loss test and it's failing and cleaning the connectors doesn't solve your problem. You need to figure out where on my fiber is the loss occurring. That's when an OTDR really comes in handy, is when you're trying to troubleshoot those kind of problems. However, when you combine OTDR and optical loss testing, you get Tier 2. So when you hear somebody refer to Tier 2 testing, it is an optional test. Tier 2 is optional. Tier 1 is required. The optical loss test is required per the standards. When you add an OTDR trace to it, in addition to that loss test, you now have what's called Tier 2. So if someone is asking you to provide Tier 2 testing, that means you need to do an optical loss test and an OTDR trace to accompany it. So when we're looking at an OTDR trace, we have a few things to look at. Now, this is a general diagram. Not every OTDR trace is going to be exactly like this. The one you're going to see that we demonstrate won't look exactly like this. Most of them won't look exactly like this, but they'll resemble this somewhat. The general rule here, when you're looking at an OTDR trace, you'll see as you go from left to right, this trace will generally go down across this as we get further and further away in distance. That is loss or attenuation. So it's a loss of power, loss of signal, if you will. So we're seeing that signal drop as we go down along the cable. The spikes that we see are what we call events. Connectors will look like this. You see a reflective spike. A splice typically will show a drop down. So you see your fiber itself is traveling in a downward direction here as we go out in distance. That's loss. Then the loss drops off and then continues in that same general direction in a downward fashion. That's an indication of a splice. Now, something that can look like a splice is a bend. When we look at this right here, we can see that this is continuing down a trend here, and then it drops down, looks a little bigger than that last splice, and then it continues. The way to tell if this is a splice or a bend, one thing you can do is look at the dual trace. So look at both wavelengths that you're tracing. I'll use single mode as an example. 1310 and 1550 nanometers are the two wavelengths. If you see that this drop is much more significant at 1550 than it is at 1310, then that's probably a bend in the fiber. And a crack will look similar to a connector, but after that spike, it doesn't continue in a straight fashion. It gets very jagged, or what we call noisy. You'll see it drop down, a lot more loss, and then it's very jagged. Now, the end of the fiber typically is going to be a big spike. That's the very end point of the fiber, and then it drops off. So there's nothing beyond this. This can be a broken fiber. So if you're looking for a break in the fiber, this is how it may appear. Or a connector without anything on the end of it that will show you a reflection, and then it just drops off. When you're looking at an OTDR event table, the symbols you see here are these events. So we see this reflective event, which is your connectors, or could be a crack or a break. The start of the fiber is this sideways T, if you will, with the long side on the left. And then the other one here, this is the far end. This is the end point of the fiber. And these will show up when we look at an event table. And we'll see those when we get to the OTDR and actually run a test. And then this is called a non-reflective event. This would be a splice. This is where we see drop. And when it says non-reflective, it really is somewhat of a reflection, but it's not a huge reflective event, and it's not showing a spike. It actually drops off. And a bend will cause this type of issue as well. So I'm going to drop out of this, and we're going to go ahead and go into our OTDR. I've got the OTDR adapter here, and it is connected to my network service assistant. And then I've got connected to that, and I've already cleaned and inspected and cleaned all my connectors. I've got a launch cord here. This is our 150 meter launch cord. I'm connected with a coupler here to another fiber that we're going to be testing, and then I've got another fiber connected to that and a tail cord at the end. Now, the reason I've got a launch cord and a tail cord, you could just test with a launch cord, but if you just have a launch cord, you can't measure the reflection of the final connector on the end of your cable. You can't really characterize how much loss you have. So it's important to understand that you'll want to have a tail cord at the end of that fiber that you're testing, in addition to the launch cord. It's the same cord. We sell them as launch cords, but you would get two of those. Use one as your launch cord, one as your tail cord. The one I've got here is actually an SC, which plugs into my OTDR adapter, and on the other end it's got an LC to connect to my cable. They're available in a wide variety. I like the SC to LC because if I've got a pair of those along with the short reference cords that come with my OTDR, we call them a connector saver, I can plug that in here. I can test pretty much anything. I can flip the cord around at the far end to use it as a tail cord. So the SC to LC really works out well. So I'm going to go into project. We're going to set up a project for OTDR. I'm going to click on Project Manager, and I'm going to add a project. And I'm just going to call this OTDR Training. And that'll be my project. And I'll click OK. And yes, I'm going to set this as my current project. Now I'll hit my back button. This is very similar so far to what we do when we're setting up a fiber test or setting up a copper test. Now we can edit the test profile. So in the test profile, we can do a few things. I'm just going to leave it at my standard limit. That's just by default. That's not editable right now. That will be a future feature. I've got my cable as single mode OS2. I'm just using the generic, but you do have the cable library in here, so you could choose your cable library if you like, just like when you're setting up other fiber tests or copper tests. The connector, I've got my SC on here. I'm testing LCs. I could put LC on here to indicate that my cables under test are LC. So I could go in and change that to generic and just change it to LC. And then operator and label scheme, it's going to be exactly the same type of setup as we've had in previous tests. You can refer to the copper project setup and fiber project setups to show how to do the editing of the operator and the label schemes and setting up label schemes in various methods. So now we're set up. So now I'm going to go back to my home screen. I'm going to go into the OTDR. And we're going to look at a few things. Now, the default here, I've actually changed my pulse width. So the default, when you first come in here, you'll have 2500 as your maximum length, and the pulse width will be 20. Now, when you run your first test, you may find you need to change a few things. So my fiber, I've got a 150 meter launch cord. I've got another 100 meters of the cord I want to test, and there's another 100-meter cord attached to that, so there's two cords plugged into each other that I'll actually be testing, and then a 100-meter tail cord on the end of that. So I've got a total of 450 meters. So I'm going to go ahead and change this to 500 meters because I don't need to look out very far. I don't have to look out to 2,500 meters. And I'm going to change that pulse width again to 25 because I know I've messed with this and the pulse width is better at 25. Now, when it's at 20, in fact, I'll show you. Let's put that back to 20. We can just use the default 20 right here. And I'll run a test real quick to show you why I set this to 25. Sometimes the trace will look a little strange, so you want to adjust your pulse width. And by changing that, you can actually fine-tune the trace, smooth it out. So I want to show you an example of what a trace might look like if you don't adjust that pulse width. And once we've dialed in on that pulse width and the max length we need for a particular project, which most of the fibers are going to be close to the same length, then we're set. So here we can see this trace is pretty messy. It doesn't have a smooth flow from left to right. There's a big drop off here. Now I happen to know there is a connector issue out here, which is why we're seeing that big drop off. But I'd like to clean this trace up a little bit. So I'm going to change that, and I'm going to change it to 25. I'm just going to back out of this test. We'll change this to 25. And then that will smooth out that trace for us. Now before we run our test, I want to actually go into settings and show you what we would want to do in settings. So we go to settings. Now I've already input my information. When you first come in here, this will be off. You'll want to turn on hide the launch cord trace. That actually makes for a nice smooth looking trace. When you hide that launch cord, it actually shows you what you want to look at. It shows you the cord under test. So you don't have to be looking at the launch cord and figure out, okay, where's my actual fiber start? When we hide it, it actually gives you a much better look at the trace. So I'm going to hide the launch cord trace. My launch cord is 150 meters. I have a 100 meter tail cord, so I've already input that information. Now I'm going to turn on the show both wavelengths in the trace. So what this means is when I run 1310 and 1550 for single mode, I can see both traces, and I'll show you that here in a moment. And then we have a limit. You can enable a limit up here. The default here is 10 dB total loss. You can make that whatever you need to. I've got a connector loss limit of 0.75 here and a splice loss limit of 0.3. So now what will happen is if I have any readings that are greater than that, I will get a fail. So I'm going to go ahead and hit my back button. Now we've got our length, we've got our pulse width. I'll leave the test time alone. You can change that. That can also affect the trace. Typically, I leave the test time alone. The one thing about OTDRs is you've got a few variables to play with. The max length, just put it to whatever that next length is just above where your longest fiber is. That's typically how you're going to use it. And then you can adjust those others as you need. Normally when you adjust the max length, the pulse width will also adjust along with it, as will the test time. So I'm going to go ahead and hit my test button now. And we can see we're running at 1310 and 1550. Note that 1550 in this case would have been unchecked by default. I had already checked it. So just make a note that if you want to do both wavelengths, you need to check that. And we do have a failure here. So interestingly, I've got 1310 passed and 1550 failed. And here's the dual trace I was talking about. So we can see we've got our first connector here. And if I go to my event table, I can see the beginning of my fiber is right here on this green cursor right here. The yellow vertical cursor here is the end of my fiber. And the way it's determining that's the end of the fiber is I've already told it I have a 100 meter tail cord. So here is the tail cord right here. So the OTDR knows that this is the tail cord between this reflection and this reflection. And we can see there's nothing connected at the end of the tail cord because it just drops right off out there like that. So what we're testing is between this green cursor right here on the left and the orange or yellow cursor on the right. And the beginning of the fiber is right there. Then we click on the first reflective event, and this tells us we have 0.1 as our loss for that connector, and that's where the launch cord mates with the fiber under test. That's this mated connection point right here. So that first connector has a 0.1, so that doesn't look too bad. We can click on the next event, which is 96 meters. It's about 100 meters out. That's going to be the other end of this fiber where I've got another fiber connected. And that's also got 0.1, so that doesn't look too bad. And then we go to the last connector, and that's this one right here, which mates with our tail cord. That's a little lossier. That's a 0.4, but it's still acceptable. And then we have the end of the fiber, which is going to be at that same point. It's 198 meters out, and if I click on that, it's going to show me my total loss is 2.4, including the connectors and the loss of the fiber along here. Now, if I wanted to zoom in on anything, we can just click above and left of where we want to zoom in and drag down and right, and it creates this gray box. Release your finger, and now we've zoomed in. So we can see, and I mentioned earlier we've got two traces here. You've got the brighter colored trace is the 1310 that we're in right now. The dimmer trace here is 1550, and we can switch back and forth between those. I'm going to exit out of my zoom mode here, and what I'll do is click on 1550. And here we can see we do have an issue right here at the last connection point, and we've got more loss than we want at 1550 in this case. So I would try typically cleaning those connectors to make sure, because it is at that mated connection point, I'd want to make sure that they're cleaned. I'd want to double check and make sure I don't have a bend in the fiber right there where my connection point is, just to make sure that I haven't done something to that fiber. So those are the things we can do to troubleshoot this. So as you move through this table, again, this is where you jump to the event. So as I move to each point in the table, it's going to jump on the trace up here. And again, I can zoom in on this loss just by dragging my finger top left to lower right on the area where I want to zoom. And then we can see now, interestingly, I see a little difference in the two traces here now that we're in 1550. If you'll notice, right before this connection point, it's a little messy. It's not smooth like it is on our 1310 trace. So this tells me I may have something going on right here. There may be a little bit of bend in that fiber right where it is at the connector, and that's showing up more at the 1550 than it is at 1310. So I'm going to close out of the zoom, and then I'm going to close out of the event table and show you another way to look at this. Some people don't like to look at the trace like we're looking at here. They want to look at something a little simpler. So what we're going to do is I'm going to click on this button down here that says Event Map. And in here, this just gives you a linear look at that fiber. So we click at the top here, that's that symbol we talked about earlier, the beginning of the fiber. And then we go to this and we see the beginning of the fiber. There's our distance is 0 because that's the beginning of the fiber. That's where it starts. And then we click on that first connector, and again, the distance is 0. That's our first reflection, and that's measured for loss. We got 0.1. We go to the next connector, which is out at about 98 meters, and we see 0.1 there as well. Then we go to the next reflection point, and this is out at the far end of our fiber, and here's where we had that loss. We had a 1.0 on there, and then we go to the end of the fiber itself. Now note our overall loss on the fiber was acceptable, but that one connection point did have a reflection. So if we had failed an optical loss test and we're trying to troubleshoot it, this may have just helped us pinpoint where that loss point was. I can look at the same thing for 1310, and again with the 1310, all of these passed. As we click through each of these events, we can see everything passed. And then we would save this test just like we would any other test with the Save button here. And when I save, I'll just use the label scheme I've got on there and click Save. This is exactly like we do any other test. And we'll cover uploading of test results in a different video. It will be the same for every test that we're doing. You will want to upload your test results if you're doing it with a USB drive. You'll want to upload those while you're in OTDR. So you'll want, if you are using the USB, you'll want to go ahead and stick that USB into your NSA or your Test Pro, and then go ahead and copy your test results. And I'm just going to select that OTDR training project. So make sure when you're done using the OTDR, if you're saving those results, before you power down, go ahead and offload and save those. Saving the OTDR results is different, and you will notice that if you're running other tests and you want to switch to OTDR again, everything is hot swappable, but when you change to and from OTDR, there is a brief power reset. It's not a full power down, power up, but the unit will automatically reboot, and it's a shorter reboot as you go back and forth between OTDR and other testing. And that's because the OTDR is actually using a different user interface, and because of that, you need to make sure that you're in OTDR testing when you offload using the thumb drive. If you're offloading directly to your PC using a USB cable with our Test Data Pro software, that process is going to be the same. It will import all of your tests, whether they're OTDR, fiber loss, copper, whatever you're running. It'll all import at once. And that concludes our OTDR training video. Thank you for your time.